second session of day 3 of ATP 2024. We have expert Dr. Deepak Punetha sir from MIT Allahabad. A brief introduction about Dr. Deepak Punetha sir. Dr. Deepak Punetha sir have received PhD degree from Department of Electrical Engineering IIT Patna and postdoctorate from IIT Bombay. His research work is focused on electronics, product design and technology, modeling, simulation, fabrication of microelectronic devices including gas sensor, nano generator, solar cell, photo detectors, etc. He has significant academic research experience in developing electronic products with several engineering and scientific applications. He has taught undergraduate programs and postgraduate programs courses in semiconductor technology over a span of 12 years. Currently, he is serving in Motilal Nehru National Institute of Technology, Allahabad as assistant professor in Department of Electronics and Communication Engineering. He holds 3 patents and published more than 80 international research papers including Nature, IEEE Transaction, Journals, ACS, RSC, Wiley, Elsewhere, Springer, etc. He has been selected for Market's Who's Who 2019, 2020, 21, 22, 23, Albert Nelson Market's Lifetime Achievement Award. He has also been recognized as Rosalind Member of London General Press and Senior Member of IEEE. He is member of editorial board of various reputed international journals and served as technical program committee member, keynote speaker, session chair for many national and international conferences. Now I request Dr. D.K. Tripathi sir to welcome our guest with a bouquet. Photo. Now I request Deepak sir to proceed with this.
First, I would like to thank the organizer to invite me here and brief about my research. So, before starting my research, first I just want to have the interaction with you all. So, you all are from BTech, MTech, but BTech only. BTech, third year, final year? First year? Huh? Okay, mix. Okay. So, like if you see here, my title of the talk, that is nano composite. This pointer is there. Pointer. Achha, no problem. So, if you see the title, that is nano composite based optoelectronic devices. How many of you know about the nano composite, or first time you heard this name? First time or first time? Fine. Optoelectronics? First time? Devices? Device I heard. Okay, fine. Electronic knows? Electronic what? You are from the electronics background, no? Knows? Okay. So, I can say this lecture is only for you, because at least after this lecture you will know about all the concept which I have mentioned here. Okay. So, the first I would like to explain here the electronic nose. Electronic nose means it is kind of some detection portion which we are talking about, where it is detecting electronically. Okay. So, I usually start my talk with this image. Have you seen this image? Huh? What happened? From where you have seen this image? This image came from the Bardeen, from the Bell laboratory. What happened? The Bardeen, the Walton and William Shockley, they invented the transistor. And everyone knows how transistor have changed the complete semiconductor industry. In the what we call in the semiconductor industry nowadays, without transistor you cannot think about any device or any sensor, any equipment, you cannot think about. They have invented that thing on 1947. For remember point of view, 1947 is very what happened in 1947? Independence, yeah. So after 9 years, what happened? They got the Nobel Prize, okay, for the invention. Okay, how we got the Nobel Prize? If you have done something, we publish some work, then people see, okay, what about your innovation and all. Later on, they will give you the Nobel Prize. Okay, so this thing happened in the 1956. They got the Nobel Prize for the transistor. Fine. Any confusion? No, no. Later on, if you see that times, this is the image, first time the image was taken for the first transistor, and if you see the dimension of this transistor, this is the transistor. Okay, if you see the dimension of this transistor, it is 3 centimeter. One transistor dimension is 3 centimeter. So this was the image was taken in 1947. Okay, so transistor looks like that one. But after 9 years, 1956, after 9 years mean 1965. What happened? Who came? Morse. What Morse says? Morse says the number of transistor on microchip double every 2 years. He said this thing in 1965. That times we were having number of transistor around thousands. So every year double, 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 double. How many of you have seen microprocessor? Have you seen anyone? Microprocessor have you seen? Computer or laptop? If you see the microprocessor, I am taking example of the i7 processor. The i7 processor having that much dimension, that much direction. Okay. So in i7 processor, if you Google, then you will find that in i7 processor we are having 731 million transistor. How many transistor? 731 million. So if you will calculate, that means 73 crore transistors. 73 crore, 731 million. Are you getting? 1 million means 10 lakhs. 731 millions, 73 crore transistor. Again the same questions. That much transistor, 73 crore transistor. I am telling you, okay, you mount 10 or 1000, 10 transistors. I have shown you, na, first transistor 3 centimeter. Here I am telling you, okay, mount 10 transistor. Can you mount? Okay. Okay, so further maybe like you mounted 100, 1000, 73 crore. So how it has been possible? How it happens? Because 73 transistor is there. Is it possible to mount in that much area? Not possible. So then why this i7 processor? Why they are telling, okay, we are having 73 crore transistor in i7? Because i7 is billion. Okay. So why they are telling this thing? Because mounted is not possible. From here two concept came. The circuitry, the circuits are of two type. Okay, one is the IC, second one is the DC. What is the definition of the IC? IC full form, integrated circuit. DC means discrete circuit. You cannot mount whenever we are telling about the mounting point of view, that means we are talking about the discrete circuit, discrete circuits. In the PCB board you have seen, so that circuit is the discrete circuit. So what is happening in the integrated circuit? In the integrated circuit, on a single wafer we are depositing different transistor at a time by making the isolations. And if you see the dimensions, so in the dimension is around nanometer. So if you will measure the thickness of your hair, it is in the order of micron. So that means thousand of transistor is equivalent to you the thickness of your hair. So that means to fabricate such transistor you need very sophisticated instrument. Okay, and for you also need some laboratory. Okay, are you getting? Because if any places you cannot have such kind of fabrications, because whenever you are breathing you are also releasing dust particle. What is the order of the dust particles? Same micron. So you need very sophisticated environment. Okay, and for that environment there are the classes, class 10, class 100. Okay, there are the different instruments are also there, like MB, molecular beam epitaxy, E-beam operation, spectring. There are so many things is there, but ultimately what is happening, we have downscale the device. Yes or no? Earlier, if you will go 15 years back, that times we were having some phone, Nokia, some 3315, some 6300, 6000. If you see, the dimension was very big, very heavy, okay, black and white kind of things. Now we are having the color phone, very small phone. Also, like if you see everything, the touch thing is also there. So how these all things have changed? How the semiconductor industry is improving every year, or why? Because the thing is, what you can do, you can downscale. That means the nanomaterial you can do. Okay, the nano things can change the entire, they have already changed the entire semiconductor industry. That's why if you have seen the process, the progress in the field of semiconductor, so every year you will found new and new devices, emerging devices are there. Okay, so it have been possible from here to 1000 to that what we call billions. It have been possible not because of only one person. There is a history. One person cannot change the world. There is a effort of many researchers, many scientists. Okay, it has been done by many researchers. So here we will try to understand about the nanomaterial, about the nanocomposite, which I have not explained so far. We have we will see in this talk. Okay, we will cover all the aspects here. So first, the nanotechnology. Okay, if you see this word nanotechnology from the name itself, it is clear that something we are talking about the nanoscale or something. Yes or no? No. So in the nanotechnology, what is happening at the nanoscale? There are some advantages. Whenever we are going in the nanoscale level, so some of the properties of the material it is changing, and that properties are the electrical property, mechanical property, optical property. They are changing, and we can use the benefit of the change in that property to fabricate a device. Okay, so what is happening in the nanotechnology R&D, like if you see, we can understand the creating the improved material, we can have the emerging devices, the new material, new properties you can define by the nano formation. Okay, so nanotechnology, by the nanotechnology, if you are exploring new era, because what is the thing, like if you are miniaturizing the device, if you are downscaling any device to a threshold, to a certain limit, you can have the nanoscale. After that, you need to replace your material, or you need to merge 2 or 3 material. If you are merging 2 materials, that is called the nanocomposite. Nanocomposite, clear? 2 nanomaterial we are mixing. Why? Whenever we need some effort in which we need the properties of 2 material irrespective of 1 material, so that times we need the nanocomposite. So by the nanomaterial and nanocomposite, we can have so many applications in the biomedical, in the like if you see the energy production, the nanoelectronics, in consumer products, there we can have the applications. Okay, if you see the brief history, so the history is very interesting of nanotechnology, because first time this about the nanoscale, the Richard Feynman in 1959 he says that we can have in future, we can have a device with the help of nanotechnology, nanomaterial. He said this thing. He said, okay, that time we were having the device by the bulk material. He mentioned that okay, we can have a device by using the nanomaterial. He said this thing in the 1959. But if you see the word of nanotechnology, this word nanotechnology, it came in the existence in 1974. Okay, and by the Norio Taniguchi, he has used first time this word nanotechnology. Okay, please understand the concept. And 1959 I am talking about this concept, how called by one researcher. These are the things. Okay, they have mentioned this term in first time 1959. Okay, if you see the history also, so there was one person, Eric Drexler. He has this written one book, and that book was very famous in 1986 times. And with his wife, he started one institute. His wife was the Christine Peterson, and they both started an institute, and that is very famous institute, Foresight Institutes. And that institute was completely dedicated to form the nanomaterials. Now, why such this institute is needed, and what in this institute they are doing? This is also the things. Na? So suppose if I am taking the example, we are having a bulk material. In the bulk material, if we are doing the confinement in one direction, okay. So what will happen? We will have the sheets, nano sheets. So we call it the 2D material. Have you seen this word 2D material? So what is this 2D material? We are having 2D shapes, confinement in one direction. If we have done the confinement in two direction, then we are having nano rod. If you have done the confinement in all three directions, then we are having quantum dot, 0D, quantum dot, okay, 0D materials. So that institute was completely focused on the synthesis part, where you can have the different form of the nanomaterial. It is not limited that we are having only this nano sheets, the what we call the nano rod and quantum dot. Apart from this thing, we can also having so many structures of the nanomaterial. So those structures we will see. Okay. So what happened? They started one institute, and that institute was dedicated to prepare the nanomaterials. In the nanomaterial, different nano forms, because nano flower, nano flags, nanosphere, there are so many kind of this shape are possible. Okay. So basically this nano structure, this nano means nano, what is the formula nano? So usually the material which is having the dimension in the order of nanomaterial, we call it the nanomaterial. And it is not this hardened core that 1 to 100 is only nanomaterial, not like that. Maybe 200 nanometers, sometimes you can also call, okay, this is also nanomaterial. Nanomaterial doesn't means that it is having some hard called some boundary, okay, this 100 is that one, to 102 is not nanomaterial like that, not like that. Okay. So in the after nano, what is happening? Starting happened from the micro technology side, microelectronics. So many times you heard the name microelectronics. Now people are also using the nano electronics. Not people are telling the angstrom electronics or something. Okay. So what is happening? It is same like I told you that you are a good student. Okay, fine. Then I told you you are very good student. Then I am telling you very good student. It is any meaning of very good? No meaning. If I told you, okay, the VLSI technology are those technology in which we are having the transistor in the order of lakhs and the millions. If you are having the transistor in the billions, so sometimes we call it the ULSI, ultra large scale integration. But in reality ULSI कुछ भी नहीं है. Okay. So in the nanomaterial, we are having different nanostructures. Those structures are nanofilm, nanocase, nanocomposite, nanofabrics, nanofiber, nanopillar, nanopin, nanorod, the quantum dot, nanowire, nanotip, so many. These all are the possible nanostructure. Okay. I told you in the 1959, he mentioned, Feynman mentioned that we can have a device by the nanomaterial. It doesn't means that nanotechnology was this term, this material came in the first time. Nanomaterial also in the environment. Okay. If you see, this is the image of the cytomegalovirus. The dimension is also in the order of the nanomaterial. Lotus effect, the water droplet, it is also in the order of the nanomaterial. Also the closure of the gecko's food, it is also in the order of the nanomaterial. And if you the example of the peacock is also in the order of nanomaterial. So further, like if you see the butterfly, so we have taken the SEM images. Our eyes having some limitations, we cannot go beyond micron. We cannot see the nanometer by the naked eye very properly. We need several instruments. One of the instrument is the optical microscope. Optical microscope is also having one limitation. What? That we can see the image by several nanometer. Beyond that, we need an instrument which is called the FSM. Okay, scanning electron microscopy. From the SEM image, we can see, okay, what is the morphology of the material. Morphology means if you are getting the nanodot, so can you see the nanodot? If you are having nanosheet, can you see the nanosheets? If you are having quantum dot, so can you see the quantum dot? Because morphology you can see by the SEM images. Okay, so this is the SEM images. If you see the SEM images here, sorry, here you can see the images, and in the nature we are having in the butterfly wings, it is also in the order of nano material. This is the dimension around 500 nanometer scale. You can see the structure. Okay. So our nature itself consisting nanomaterial. It is not only nature. If you see the Brazilian crystal, the era, if you see the long back era, the Roman era, 4th century, there was also if you see that the crystals, the diamond, if you see their crystals imaging SEM image, it is also in the nanomaterial. And also if you see their arts which they were using in the Roman era, it was also in the order of the nanomaterial. They used that times some silver post they usually use that time. If you see that silver spheres, it is having the dimension 100 nanometer, 80 nanometer, 40 nanometer. So this was the scale they were taken. So that means what was happening? They were synthesizing in the nanometer, but that time they don't know what is the name of this method. They have not given any kind of method. This all thing came after 1974. Are you getting? It is 4th century which I was talking about. Now you can think about the that time also our this science and technology. They were having such a dimension 40 nanometer, 70 nanometer dimension. They were synthesizing that era. In 1974 we have given some technique name, maybe like name I am telling the hydrothermal synthesis, the hot injection method, and many methods we are telling. Now we have given the name. You use this name, you are using this methodology, this is this name. You have to use this methodology, this is this name. That time they were not having a name, but they were very expert. Okay, so if you are thinking okay, we are like the scientists or something, so in the 4th century they have done this all thing. Okay, so the classification I already discussed. Based on the confinement, we are having 3 kind of material. 0D means we have done the confinement in all 3 directions. Okay, the quantum dot and all, and if we have done the confinement by the 2 dimension, then we are having the narrow dot. In 1 dimension confinement, that means nano sheets. Fine. इसके बाद 2D मटेरियल कोई पूछेगा ना तो ये नहीं बोलना कि नहीं पता, ठीक है. हाँ, next this is the morphology, how it looks like. 0 dimension look like this one, ठीक है. 1 dimension, this is the narrow dot we have tried to show you how it looks. The CNT carbon nanotubes, this all things you have heard in many, maybe in the news and all. The sheets, the 2D sheets, the graphene sheets. Okay, so these all are the 2D material, MOH2 material. Okay, these are the 2D material. 3D material is the graphite and many things we are using as the 3D bulk material. Okay. So what is happening basically whenever we are forming the nanoparticle, it is not only it is limited to the downscaling, it is also having some other advantage like it is having the electrical charge potential, it is having some compositions, it is having the dimension and morphology. What is happening? I am giving one example, simple example. Suppose if this one is my surface, this is the surface of a device. Okay, in the surface area we are having that much surface area. Okay, in the surface if we are having some nano dot, so our surface area will increase. Yes or no? Linear or nano dot, so surface area will increase. So by the forming the nanoparticle, we can have the surface area, high surface area. So how it is connected to our device, this thing we will see. We are understanding this concept by taking example. You all are the engineering student, engineering background. So here we will see the example. Sorry for that. We have taken a block, okay, and we have cutted this block in 5 portions. Earlier there was a surface area S, and now we are having the high surface area, means 2s, 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 we are having the surface area increase. The same concept I am explaining by this route. You will understand this concept very easily. Here we have taken one sphere. So what is the area of the sphere? 4 pi r square. And what is the volume of the sphere? Very nice. If we have formed thousands of sphere having the r by 10 resistance, r by 10 radius. Okay. So if this is the radius is the r by 10, so what is our surface area? How much is the surface area? Okay, are you getting? Like if you see the surface area is 4 pi r by 10 square, and the volume is 4 by 3 pi r by 10 cube. If you see the volume of this one, so it is 4 by 3 pi r cube by 1000 na, and if you will add the 1000, so the complete volume of this all is the 1000 into divided by 1000, that means same volume. So that means this volume and this complete this 1000 volumes are the same volume, fine. But if you see the surface area is 4 pi r square, it is having 4 pi r square by 100, and what is the surface area of the 1000 sphere? 10 times 1000 by 100, 10 times. So that means if you are measuring surface to volume ratio, so it is 10 times. So that is why in the device point of view you will see all the cases that we are measuring the surface to volume ratio. Why was surface to volume ratio? This is the reason. Okay. So by this thing you can have the improvement in the performance parameters. So this is the beauty forming the nanoparticle. Okay. So here in the nanomaterial there are some general properties like the band gap and other things, it changes. Surface to volume ratio we have seen. Apart from this thing, band gap also varies, and this already I explained about the surface area, and then also the magnetic property also varies. Suppose if I am taking example of the gold particle, so if you are forming the nanomaterial, if you are forming the nano size, like this bulk gold and platinum are non-magnetic, but at the nano size it is showing the magnetic property. So what is happening, suppose if you need a material in some manners where you need some magnetic property, so you can have the nano compositions, nano formations, this thing you can do. So what is happening, by the nanomaterial also you can have the change in the parameters, the properties like magnetic properties you can also tune. Same like optical property, a material like if it is looking like some red color in some manners, so maybe it will change to yellow or maybe some purple color or blue color based on the confinement. So what is happening, like that there are some other parameters like photocatalyst property, photoconductive property, photoemission property, electroluminescence property, these all property vary. A nanomaterial having different property, bulk material having different property. So this is the beauty of the nanoparticle. So that is why if you see any kind of electronic devices, then you will found that we are using towards like the nanomaterial only. Okay, same in our transistors. Electrical properties, the band gap is directly related to the electrical properties. So what is happening when the size becomes comparable, then with the de Broglie wavelength, so electron particle property, the electron converts to the wave-like properties, and thus the continuous energy bands become discrete energy states. When we are having this energy level, you know, energy levels we are having, so we are forming the nanoparticle, then we are having the discrete natures. Okay. So that is why what is happening in our, why we use semiconductors, semiconductor क्यों use करते हैं, semiconductor कंट्रोल कर सकते हैं, हाँ, very nice, so very good. The beauty of the semiconductors, that the what is happening, our current, the conductivity is depending on the carrier concentration. So the carrier concentration range of the semiconductors is very wide. So we can alter the conductivity from an insulator to from a conductor. So this is the beauty there. And what is happening with the transportation, basically everything is about the transportation, means how it is varying, how it is this current outside, कुछ बाहर अच्छा शायद, हाँ. So what is happening, same in the nanomaterial. In the nanomaterial we are having we are having the discrete structure. So what is happening here, I think you have heard some concept like the what we call there are the barrier is there na. So yeah, so tunneling and this thing, have you heard tunneling क्या होता है, हाँ, ओके, जो वर्ड में बोल रहा हूँ ना फिर पढ़ना भी है, ठीक है, हाँ. So what is happening, basically we are having the property, like if you see the nano formations, so we can make a device in which we can have the importance of this tunneling effect, in which like that there is a transistor nowadays, SET, single electron transistors. You please understand the concept, the BJT and MOSFET which you cover usually in the curriculum which you have studied so far. So that is the things which invented so very back, but nowadays if you see the current era, we are having this beyond, we are having the this technology. We are having nowadays the SET, single electron transistor, these all things we are having. So in which we are dealing with the electrons, single electrons. So that means we are having the concept of the tunneling. So this all things, for things you need the discrete natures. So this is have been possible by formation of the nanoparticles. Energy band gap is also becomes dependent on the nanoscale dimensions. So these property which I have also mentioned in briefly, that electrical property changes, magnetic property changes, catalytic property, mechanical property also changes, because like if you are taking the graphene, so oxides, the reduced graphene oxide is the new concept which came. So formation of the reduced graphene oxide, it is improving the mechanical stability in your devices. So that is why many places you will found the word RGO, reduced graphene oxide, very popular terms nowadays. Same like optical property, spherical property, biological property changes. Okay. Now I am giving the example of the metal oxide. Now I am coming to my domains. I am connecting you from this concept to my era. So because I will disconnect all the concept in related to the electronic noise. This is my objective. Okay. Here I am taking example of the metal oxide. What is the beauty of the metal oxides? Mostly metal oxide is, it's kind of wide band semiconductors. So this is the beauty of the semiconductors, this metal oxides. Okay. So it is kind of wide band gap semiconductor. Wide band gap means ज़्यादा band gap होता है, ठीक है. Like if I am taking example of the Xenon, so it is having the 3.37 electron volt band gap. Okay. Silicon का कितना होता है? क्या? अलग-अलग बोलो. हाँ. So what is happening? So because of the larger band gap, we call it the wide band gap semiconductors. In the metal oxide, what is happening? The S cell of the metal oxide are completely filled. Okay. So that the most of the metal oxide have good thermal and chemical stability. So what is the beauty of this one? For like if you need a device for some application, maybe 400 or 500 degrees Celsius, so your material should not degrade. ऐसा नहीं होना चाहिए कि आपका material room temperature में अच्छा चल रहा है, and when you raise the temperature, then your material is not working or maybe burnt or damaged or something. So the all metal oxide having the good property towards the thermals, the temperature, also the chemical. So that's why it is having the ease of processing when we are forming the formation, when we are having the deposition or something. If you are having the multi-layer depositions, so it is having the advantage. And if you see the D cell of this metal oxides, it is not completely filled. So because of this thing, what we can have, we can also form the nanocomposite, we can have the confinement, we can have the applications by the nature of this thing. Okay. In the nanomaterials, by this nanostructure metal oxides, we can have the high surface to volume ratio which we have seen so far. Okay. Also the the catalytic efficiency improved, the strong absorption ability I will focus in maybe 2-3 slides. I will completely focus on what is this phenomena. Okay. So nanomaterials, this oxide is having the possibility, if you need a device which is high sensitive and for this high thermal stability, high chemical stability, so the nanomaterial metal oxide are very useful. Okay. And this metal oxide, mostly metal oxide, is act as the optoelectron devices. So optoelectron devices are those devices in which you are having the applications, it is directly towards the visible lights. Okay. So by the formation of the optoelectronics, you can have this LED photodetectors or also the solars and all. Okay. So the metal oxide, there are so many kind of metal oxides, the titanium oxide, the tin oxide, zinc oxide, tungsten oxide. Okay, there are so many kind of metal oxide which you can use based on the literature and based on the applications, and there are so many applications also associated with these metal oxides. Some applications are the gas sensors. My primary research towards the gas sensors, this thing I am telling you. Actually I have done my research on the gas sensors. Later on I spread this field towards the renewable energy. Okay, basically nowadays I am working on the solar cells, and in the solar cells, along with solar cells, I am working on the nano generators. Nano generator किसने नाम सुना है? Have you heard nano generator? हाँ? What is nano generators? Nano generator kind of piezoelectric. Piezoelectric का नाम सुना है? क्या होता है piezoelectric में? Very nice. Where we have given any mechanical, it is converted to the electrical. So like that, I am working on the nano generators in which we can make a device self-powered. If we are having some pressure, some deformation, so it will generate the electricity. How it is generating electricity, I will show. Because we have studied the things, we have studied the response, and we have operated a device without any power supply. We have made a device self-powered. So now what I am doing, the all sensors which I have fabricated so far, I am making a device, a flexible device, a electronic skin which you can wear, and itself it will generate the charges, it will generate the voltage, and itself that charges is enough to operate the device. Are you getting? Because now the thing is, now the question is why this concept is needed, why this nano generator concept needed. In the present era, 32% power we are generating by fossil fuels, means by burning coals. How it is affecting environment, everyone knows. Every time new disease it is coming to in the existence, this thing you have heard now. So what is happening by this thing, so many diseases coming, so this is the time where we can think about the renewable. In the renewable there are the wind energy is there. What is the problem with the wind energy? So much space needed. And we are also having the alternate to the solar cells, which people are also using. And the another thing is the nano generators. This concept, the theory of this concept is very old, like the MOSFET and the BJT. Theory of MOSFET was very old, but BJT fabricated first. Like that, theory of this nano generators is very old, but maybe because of some challenges or something, this is not that much implemented in most of the countries. In China they have implemented. Chinese people are very smart. Okay, like if you see now, sometimes we are telling, okay, our we are having some limitations, we are having some problems, you can make that problems your strength. We are having so much traffic na, so in the traffic if you are having some speed breaker or something, so you can use that concept there, so that it will generate the electricity, and you can operate some transportation system based on that generated powers. This thing we can do. So like that we are having things which I will also cover. So here this was the content. Here I was explaining about the theories, so that it will connect you with the research portion. Any confusion so far here till this one? Any confusion? Confusion batao. English comfortable, Hindi also comfortable na? Bataiye. Should I go ahead? Thank you. So okay, here we have seen the metal oxide, the nanomaterial, this thing we have seen. Now I am going to the gas sense. Also we are calling it the electronic nose. Electronic nose, both are same thing. It is detecting electronic nose, gas sensors. Yes. So basically I start usually explaining this concept by explaining the term the sensors. What sensor does? It convert physical parameter into electrical signal. That is the thing. Okay. So there are two kind of sensors, active sensor, passive sensor. In one sensor we need some power supply, in another things we don't need any power supply. In the this what we call passive sensor we don't need, active sensor we need power supply. So suppose if I am telling from the gas sensor comes from that that phenomena, what is happening in the gas sensor, we have given some voltage, 2 volt I have given to a device, 2 volt यहाँ पे connect किया, I am getting some resistance, maybe 300 kilo ohm. If some gas came in what we call in the sensing layer or something, so it will give some charge transfer reaction, so we will get the change in the resistance. So that is the simple working. It looks like simple, but when you measure there are so many things are there, but theory is very simple. Gas आया, charge transfer हुआ. How it is happening? This thing I have shown here. If you see the nature of the gases are of two types, oxidizing and reducing. If I am taking example of the reducing gas species, like CO I have taken. See CO, in the metal oxide we are having oxide ions. So CO plus oxide ions we are having CO2 plus electrons. That means we have got some additional electrons. That means our conductivity will increase. That means resistance will decrease. So we will measure this change in the resistance here. Are you getting? Vice versa in the case of oxidizing. Oxidizing, it is taking electrons. That means conductivity will decrease, resistance will increase. We measure this concept only. Very easy. Yes. So basically this is the surface. So what is happening, gas is coming on the sensing layer, we need some material here, some sensing material which we will take place in this adsorption process. So basically this process is called the adsorption. There are two processes, absorption, adsorption. Absorption क्या होता है, absorption is a volume based phenomena. क्या होता है, इसमें complete volume involve होता है. In the adsorption is a surface based phenomena. ठीक है, इसमें क्या होता है, surface पे आता है. So gas sensor basically what is happening, it is a surface based phenomena. Why? Because you also need the regulation, you also need the recovery. So that's why you need any reaction on the surface only, not the entire volume. एक बार, क्योंकि एक बार सेंस हो गया फिर दोबारा होगा नहीं सेंस अगर एब्जॉर्प्शन वाला फिनोमेना होगा तो. दैट्स व्हाई वी नीड द एब्जॉर्प्शन बिहेवियर. ओके, सो इफ यू सी द टाइप ऑफ एब्जॉर्प्शन, देयर आर टू काइंड ऑफ एब्जॉर्प्शन, फिज एब्जॉर्प्शन एंड केम एब्जॉर्प्शन. फिज एब्जॉर्प्शन क्या होता है, सपोज इफ दिस इज माय सेंसिंग लेयर, हियर सम गैस स्पीसीज केम एंड इट adhere है only, it is not making any kind of bond, it is kind of coordinate bond. Coordinate means आके हल्का सा चिपक गया है only because of van der Waals forces, and that nature of the forces is very weak. चिपक गया है, ठीक है. What is happening in the chem absorption? It is making covalent bond, it is making proper bond. So that is why if you see here, if we have raised the temperature in the case of this fissure absorption, if I raise the temperature, it is very weak this van der Waals forces. So that's why adsorption, rate of adsorption will decrease. ठीक. In the chem absorption process, when I raise the temperature, it increase then decrease. Why? क्यों हुआ? क्योंकि जब हम लोगों ने केमिकल बॉन्ड था, when we have given the temperature, it is acting like activation energy, bond और strong होने लग गए. After a limit, bond start break. So that's why we are getting increment and decrement. So the gas sensor having the phenomena of both two, where chem absorption dominates. Okay. We are also having some properties like gas concentration characteristics. Concentration characteristics means here if we are measuring any gas, so we need some concentration. So visually we are talk about here in the order of ppm, ppb, ppt, parts per billion, parts per million, parts per trillion. So what we are doing here, we need an environment. If you are telling about parts per million, million is not that much easy also. So that means from the reference you will put some 1 million, from the this testing you will put one particle, then it is 1 ppm. Are you getting? So like that we need a environment, we need some sophisticated system. So that is called the MFC. What is MFC? Mass flow controller. So from the mass flow controller we pass the gases and we make the assembly. I will show you how it looks like, how we do. Okay, this thing, everything I will cover here. Okay, so this is the gas concentration characteristics. Okay, we need some concentration. Apart from this thing, operating temperature plays a vital role, which this thing we have seen so far here, temperature role. In which temperature you will get the maximum optimized sensor response. This thing you can see here. Sensitivity, basically sensitivity is defined as the ratio of the resistance. Resistance is varying, na? Because mostly whatever concept I have shown you, is this all concept are based on the resistive sensing. So sensing will change, okay, based on resistance will change. So sensitivity is defined as the ratio of the resistance or change in resistance upon the initial resistance. So sensitivity can be defined by many manners. So basically change in resistance, okay, means resistance variation we are getting here in the terms of ratio or in the terms of change upon initial. Okay, then selectivity. सेलेक्टिविटी क्या है? कभी कभी नाम से भी कॉन्सेप्ट समझा करो, ये बात सुनो, कभी भी नाम से भी बहुत से कॉन्सेप्ट आ जाते हैं. सेलेक्टिविटी क्या है? गैस करो. बोलो. यूर गैस सेंसर शुड बी सेलेक्टिव फॉर अ पर्टिकुलर गैस. ऐसा नहीं कि सभी गैस के लिए तुम्हारा अच्छा रिजल्ट आ रहा है. सो व्हेनेवर यू आर टॉकिंग अबाउट द सेलेक्टिविटी, यूर गैस सेंसर शुड बी सेलेक्टिव फॉर ओनली वन गैस. सो दिस कॉन्सेप्ट दैट मीन्स यू नीड टू मेजर other gases as well to show the selectivity behavior. Response characteristics, basically what is happening, you are, suppose if I am telling the resistance 300 kilo ohm, then the resistance decreases like 120 kilo ohm. So maybe it is taking some time to 300 to 120 kilo ohm. So the time taken by the sensors, okay, from 300 to 120 kilo ohm, so the 90% equivalent value, because what is happening in the last night is taking so much time in the last moment. Here is not board, that's why I am not drawing here. So it is taking some time. So 90% of the equivalent value we call it the sensor response. I think here I can use or something. Yeah, better. Okay. suppose my resistance is this one, okay. Here I have used some reducing gases, here gas is in, fine. Now resistance will vary. So resistance is varying, like suddenly it is goes like that, then later on it looks like this one, this one, this one, it will saturate somewhere. Maybe it is saturated here in that point it is saturated. So we will measure the 90% of the value, that means here only, yes or no. So this value, this is your time, this was your resistance, okay, and that time the 90% of the value of this thing, that is called the response time, respond time, means how much time it is responding, okay. And here suppose if you are start from here, then again it is having the same kind of property, from like you have done gas off here, you off the gas, here gas off, now it is again going to its initial value, it suddenly it will go like that, then again it will take some time, and like that it will saturate at some point, maybe here it is saturating. So 90% of the value is same like this one, and that period is called the recovery, that is the respond, it was the respond time, and that was the recovery time, and that completely behavior is called as the response characteristics. Confusion? So this is the response characteristics which is needed, okay. इसको हटाने के लिए ये this one, fine sir, thank you sir. So that was the response characteristics. Now the another thing is the very important parameter for all kind of device is the stability. Your sensor, your any kind of device should be stable for long period of time. Time means it not only limited to the hours, maybe days, week, month or year. It's not that you need a sensor, it will work only one time. Maybe in a day also it should work on, maybe like if you are using some device, so for 5 years it is only worked only for 1 day or something, then it is giving the response. It should not look like that one. Your your device should be stable for a longer duration, okay. So this is also important parameters. So for any device, okay, so this was the sensing chambers which I was talking about. So this is the device which it looks like. We usually use the interdigited pattern. Why interdigited pattern? Because here we are telling about the resistive sensors. So in the resistive sensor, change in resistance, so we need the high resistance things, okay. So that's why we use the interdigited pattern, and this is our chamber. If you see our chamber here, okay, this chamber, so this is a chuck here, here we have mounted our samples, and here we are having 4 manipulators. Manipulator means from where you take the connections, and from here this is the your MFC. Along with MFC we have connected one device here, that is the humidity sensor. Why humidity? Because if you are measuring any sensing, so you should know in what humidity you are getting that sensor response. So for different humidity, because humidity also having humidity also affecting the sensor parameters, sensing parameters. So that's why we are having here humidity. So this is the chamber, and along with this thing we have also used the concept of different lights, because semiconductor property, the material property usually changes, whatever will change only by only 3 routes. One route is the temperature, another route is the doping, and third route is the illumination. Only by these 3 routes material property changes. If you have heard any other routes, that means that other routes which came only by these 3 things. Suppose if I am telling nanoparticles, so nanoparticles also you came by this thing, by temperature and all, by confinement and everything. So these are the ways to change the material property: temperature, doping, illuminations. So that means illumination concept we can also use here. We have used some LEDs to follow the LEDs, material property will change, and we can have the positive impact on this thing, and we can have the improvement in the sensor response. So that is why we have used the concept of LEDs there. Also this is the gases, the reference gases. Usually there is a beauty of the nitrogen gas, that nitrogen it's not falls on the inert gas category, but it will act as the inert gas. So that is why usually for the environment we use the nitrogen. Okay. So this is the sensor chamber, and we use the kilometer, the what we call the source meter for measuring the IV. So usually we are getting the IV in the nano amperes on this thing, and sometimes maybe femto if you are having some gases like hydrogen and all. So for room temperature usually you will get in the current in the femtoamperes, but usually nano ampere for the metal oxides. For flexible samples, femto. To like if you are working in any area, so you should have some motivation. Okay. So motivation is, if you see the past history, so many accidents, so many things happens only because of the leakage of the gases. So why we are using these gases? Because without these gases, our all this industry they will shut, because everywhere there is a need of the gases. Sometimes these gases are like for processing, na, you need some gases. The leakage having the adverse effect, but we need it. So for leakage we need the sensors. Okay. And if you see the what we call one image, I think here gone or somewhere. Okay. If you see the sensor market also, so there is a need. If you see the need is increasing. Share market, this is the market, US gas sensor markets. It is given by the Grandview Research. So it is increasing 7.9%. This is the market cap they have shown you. So there is a need of the gas sensors. Okay. So what is happening? This gas leakage is not only restricted to the humans. Environment also having some the gas productions. Like if you see some natural sources like here, sometime forest fire is there, the thunderstorms. Also there are some gases also releasing. So those gases are the NO2, okay, H2S, hydrogen sulfide. It is coming from the environment also. We are responsible. I am not denying this point, because human are the main. Like if you see the main source is the human for the pollutant. Okay, but nature is also having the effect. So what the things that this is the report of the WHO. WHO's 2020 WHO mentioned this thing, that 4.2 million deaths, that means 42 lakh deaths per year due to ambient outdoor air pollutions. Many diseases, many things happens only because of the air pollutions, and 3.8 million deaths per year due to household air pollutions. So that means we are like everywhere there is a pollutions. Are you getting? So we need to think about the first you if you are having some vehicles or something, so either you use like 2 persons are going in some places, so only use one vehicle or something. So also you can use the cycle and all this thing. I think in the campus you can use only cycles, na? So the effect of poisonous gases on the human and this thing. So basically what is happening, if you see the poisonous gases, the toxin in the high concentration, and we are having the human the respiratory system is also damaged because of the poisonous gases. It is having the lung tissues, asthma, many diseases. Okay. Smoke is also because of the toxic poisonous gases. Acid rain and this acidic lakes, I think you have seen. And also like if you see the corrosion in the corrode metals, the Taj Mahal is the example. Now they are cleaning. They have done so many times different things. So because of the nature, we are also having some acidic nature because of the gases and all. We are having the adverse impact of the gases. So this is the market value I have shown, that in the if you are fabricating a device from the industry point of view, maybe like if you want to start your own company in this direction, so you can also think about, because there is the need of the sensors. From it is started in the near future also, there is a huge demand. Government also have taken steps. It's not like that government is not doing anything. Government starts, sometimes people are not taking it very seriously. They have started the concept of the PUCC, but what is happening sometimes, like I have seen, like if you are taking the image of your vehicles and they are sending in your WhatsApp, okay, this is your PUCC certificate, without going, without visiting. This thing also happening. So the problem is, whenever the government is taking any kind of initiative, so the person are thinking, okay, how we can break the things. So that's why what is happening, government have started one scheme in which the vehicles will measure the pollution inner side, from the inside cabin they will measure, and directly it is connected to the server node. So very soon you will get the concept, because the transport ministry, the portal, you will see the concept of this PUCC. So they are going to start maybe in couple of months or year. So they will start this concept, and is very much needed in our this particularly this generation. Okay. So here I am telling this all concept, everything I have briefed. So now if I am directly showing you the results, so we will connect how we are getting, how, what is about those results. Okay. So what is happening, usually I have started the fabrication by the metal oxides. So for the metal oxide I started with the zinc oxides, okay, because the binding energy is very high and the thermal nature is very good. So you can use that those nature for the high temperature application, the thermal behavior. And when we have given different gases, different concentration, this is the concentration and this is the impact, this is the resistance variation you can see here. Okay, this is the resistance variation. Okay. So what is happening, when you are increasing the concentration, so your resistance and change in resistance is increasing, and you will have the sensor response we have measured by the ratio of the resistance here. Okay. So if you see the dimension of the sensors, it is in that dimension I have shown you, very small. In itself it is having so many sensors. So dimension is by naked eye you cannot see here. This one is also, are you getting how much, how small this one? So it is also having here, this is the 300, that means in the order of the nanometers. So by the naked eye very difficult. Okay. So by what we have done, again we have made the compound of our this metal oxide. We have done the compound like magnesium zinc oxide and cadmium zinc oxide. Because of the change in the polarity, we have got very what we call very selective results toward the cadmium zinc oxide. And here if you see this behavior, we have gone through this behavior, temperature first increasing and decreasing. Why we are getting this nature? टेम्परेचर के साथ बढ़ रहा है फिर घट रहा है, क्यों? कौन सा कैमिज ऑप्शन? हाँ, कैमिज ऑप्शन, समझ आ रहा है? कैमिज ऑप्शन, टेम्परेचर इंक्रीज डिक्रीज, वी हैव शोन ना, एक्टिवेशन एनर्जी, बॉन्ड बिकम स्ट्रॉन्ग, then bond break. So we have got this nature only because of this. Okay. Later on we have formed the nanocomposites. We have mixed, we have fabricated the nanomaterial, and then we have we have composites, both material. We have started with the RgO and W3, tungsten oxide and reduced graphene oxide. Here this concept you can ask, sir, like if you are increasing the compositions, here this is the pure, black one is the pure, sorry, black one is the pure, and this what we call red one is the 1%, blue is the 2%, then 3% decrease, 5% decrease. Why you are getting that much change? Yes or no? अगर बढ़ा रहा हूँ RgO तो एकदम से बढ़ गया फिर कट क्यों गया? What is happening? This W3 is the nanorod, nanostructures, and this RgO is the sheet-like structure, 2D material. So when I form the compositions, so what is happening? It is having the nano structure, na? 2D material, nano sheets. So high surface area. When I further increase, so high surface area. After further increase, maybe RgO is wrapping around your nanorods. Nanorods, what is happening? Wrapping around means nanorod तो गायब होगी, समझ में आ रहा है? If nanorod is wrapping around, that means decrement in the sensor response. Why we are getting this higher in the 2% RgO? Only because of high surface area. Later on, wrapping around समझ में आ रहा है ना, घूम गई ऊपर से, ठीक है? That's why after a limit we are getting decrement in the sensor response. Same behavior we have seen for another nanocomposites. For the temperature we have also studied the sensor response, and same properties which we have seen in our chemisorption process we have also got from here. Okay. So this was the thing which we have done so far. Later on we have tried to make this device as the flexible. So what we have done, we have used a material, this is very known material, after a period you will see this material, very famous material. We have used the PVDF, polyvinylidene fluoride, PVDF material. PVDF is a polymers and it is a piezoelectric polymers, in which whenever you are applying any kind of a deformation, it will generate the electricity. So we have used this material because it was the polymers, you can have the electronic skin by using this material. So what we have done, whenever we are making any composites, so we need, whenever we are playing with the flexible, so we need the polymers in the order of matrix. So as a matrix we use the PVDF, 90% we have used the PVDF, and the another composition we have used the tin oxide and reduced graphene oxide. You will surprise, like if you see the 1978 when this gas sensor concept for first time. So first the gas sensor fabricated by using tin oxide. Okay. So we have used this concept and this was the processing steps which we have shown, and we have also got this what we call for this research we have got the appreciations. Later on we have extended this word. I will show you how we extended. So first I am showing you the same concept of the material properties, like I describe you the illumination property. We have used the light assisted structure, light assisted nanostructure W3 thin film. Means the W3 nanostructures were fabricated sensors we have seen. So what we have seen here, if we are having sensor response, if you see here 5.11 was the sensor response. So this was the sensor response without any light. Okay. And if you are given some illuminations, so the same sensor having the sensor response 7.32. Are you getting? So that means by the illumination you can increase the sensor response. Yes. Later on what we have seen, the another things in which you can have the increment in the sensor response, we have used, like if you are having some identical sensors and if you need higher sensor response. So what we have done, we have formed the array. So what we have concluded here, if we are forming, what forming? If we are forming parallel or series array, so parallel array we are getting high sensor response. This is the good thing which we have observed here. Okay. Then that concept which I told you, nano generation concept, the PVDF concept, we have we have extended that word, and we have fabricated another device based on the same composites. Composites we have changed here tungsten oxide, because tungsten oxide is having the polarity towards the NS3. So we have fabricated a ammonia gas sensors where we have used the same material, this material PVDF. The beauty of the PVDF is its temperature, its melting point is 177 degrees Celsius. So that means like if you see our environment conditions, so that means every environment you can use. कहीं पे ऐसा तो नहीं है कि 100 डिग्री सेल्सियस टेम्परेचर होता हो, no ना. So for this thing our materials is well suited. Most of the this polymers, most of the this flexible materials, they are having limitation of the stability. क्या होता है कि stable room temperature में stable नहीं होता. So this is the stable. इसको कोई दिक्कत नहीं हो रही. इसको जरूरी नहीं कि if you need to keep this material in some desiccator or something. Environment में ऐसे रखो. ठीक है, 5-6 साल पुराना फैब्रिकेटेड डिवाइस आज भी हमारे ऐसा हवा में रखा हुआ है, कुछ नहीं हो रहा. So this is the beauty, another beauty of this polymers. Okay, and the another things of this polymer is this is a piezoelectric material. So what is the beauty of this piezoelectricity? Piezoelectricity, if you see the concept, so if we are applying any kind of force, ठीक है, अगर हम लोगों ने फोर्स अप्लाई किया तो जो चार्ज होता है वो होता है F इंटू डी. F क्या है? फोर्स, और D क्या है? पीजोइलेक्ट्रिक कोफिशिएंट. ठीक है, समझ में आया? F इंटू डी. तो हर एक मटेरियल का एक पीजोइलेक्ट्रिक कोफिशिएंट होता है. लाइक every material having their this resistivity, same like every polymers having their piezoelectric coefficient. Also metal oxide also having the piezoelectric coefficient. So that means piezoelectric coefficient for any particular is same. Another material different, another material different, same material same. ठीक है. अब आ जाते हैं फोर्स. फोर्स इज A डेल्टा T by T into E. A क्या है? क्रॉस सेक्शनल एरिया, डेल्टा T डिफॉर्मेशन, T थिकनेस, E यंग मॉडुलस. यंग मॉडुलस की क्या डेफिनेशन होती है? स्ट्रेस बाय स्ट्रेन. इफ यू विल पुट द पैरामीटर्स F, वोल्टेज क्या होता है? देखो आउटपुट वोल्टेज Q इक्वल्स टू CV, V इक्वल्स टू Q by C. समझ में आ रहा है ना फॉर्मूला? तो यहाँ पे आउटपुट वोल्टेज क्या हो जाएगा आपका? C क्या हो गया capacitance, epsilon 0 epsilon r A upon T. So what you have seen here, your cross sectional area cancel out, yes or no? Cross sectional area cancel out हो गया है. So your output voltage is depending on the piezoelectric coefficient. So that means it is depending on the material. Delta T means deformation. ठीक है. E again young modulus, that means stays sustained. Another thing is the material, epsilon 0 epsilon r, permittivity. Fine. So what is happening whenever we have then we have seen studied this sensing property. Sensing we have discussed so far. We have for different selectivity we have seen, we have passed different gases and we have seen in which particular gases it is giving the selective natures. For this thing we have also seen the stability for different days, and also we have seen the reproducibility. The same sensor for different times we have measured and we have seen how much difference we are getting. So only 4% deviation we have got for our sensors. Okay. So later on what we have done, we have applied different pressures. So whenever we have applied different pressures, so it is generated some voltage. ठीक है, different voltage मिला. Same thing we have fabricated different 14 different configurations of this nano composites. So different configuration we have got different voltage generations, and we have also studied this thing for the what we call for our daily life, like running, jumping, walking. We have also considered this thing, and we have got the generations. It's not only restricted to only jumping, running, and this thing. We have also seen the bending natures. When we have studied the bending, so different bending we have got the different voltage generations. The range of the voltage generation was not that much high, but at least we got some generations. That is in the range of 0.15 or 0.13 this thing, but we have got the generations. After that what we have studied, we have also studied the muscle motion. Suppose if you are smiling, okay, and if you have forearms, if you are stretching, so it is also having some deformation. So we have also studied the muscle motions. Okay, we have also seen the stretching, and in every situation we have got the voltage generations. A maximum voltage we have generated 15.4 voltage open circuit. So the thing is our dimension of the sensor is only 2.5 centimeter into 2.5 centimeter. कितना छोटा दिख रहा है ना? Thickness was 140 micron. समझ में आ रहा है? 2.5 centimeter into 2.5 centimeter. Thickness was 140 micrometer. That was the size of the our sensors, and we have without any power supply we have given pressure. For the demonstration we have charged the capacitors, charging, and after that 6 LEDs in a row we have glowed. So that means without giving any power supply we have operated 6 LEDs in a row. Are you getting how much? The glow was not that much perfect, but the 6 LEDs at least you are operating. So by such small dimension we are generating that much amount, but if we are using such technology in some larger scale or somewhere, so where we can have the good results, the higher generations. Many countries they started, China already started, but other countries they are working in this direction. Maybe in a couple of years you will see this concept. Now people started to do the research in this area, but later on you will see this concept in the new era, because now people are only thinking about the power generations, renewables. Now, so this concept we will study somewhere in later on. Okay. So right now I also use the same concept. I worked in the when I was in the Bombay, IIT Bombay. So that time Ram Gopal Rao sir, Ram Gopal Rao, have you heard the name? Previous IIT Delhi director, now he is the chairman BITS planning. So I worked in his direction, in his lab. So he was working in the explosive gases, RDS, HMS, TNT. You heard this name? So these are the explosive materials. So what we have done, we have fabricated a gloves. That gloves is enough to detect a gas. That gloves is enough to operate a device. Are you getting? So we are started applying the patent in this thing. Okay. So what is happening? We have used different. This is very high. This very explosive. PET and HMX. This TNT very explosive. RDX very explosive. So these all having nature. These are not gases. Basically, there are two kind of things: gas and VOCs. खाना खाते हो? खुशबू आती है, क्या गैस होती है, खुशबू, क्या है खुशबू, VOCs, volatile organic compounds. So these are the VOCs. So for VOCs we need an instrument. So this is the OVG, Olstrom vapor generator, from which you can generate the fumes. Fumes means VOCs. So this is the detection unit. What novel thing which we have done so far, actually some of the results I have not shown here because they are the part of a patent and some publication, so that's why I have not here. So what is happening here, we have improved further response. This is not have done so far. We have improved the sensor response by the UV lights. If you see here some UV or some UV things you can see here. So by UV 10 times sensitivity changes, sensitivity becomes 10 times. This concept which we have seen here with this flexible nature for this highly explosive uses. So and another things we have used the same material, because what is happening, like if you take the actually there I have also worked with the Deepak Khakar. D.K. Khakar was the previous IT Bombay director. If you will Google the name Deepak Khakar, if you go in his web page, so first will come his research interest, and directly he is listed here there in his page that he is oriented towards PVDF. You can Google, everything is the Google nowadays, you know, whatever if anyone is telling, so you can search out. So in that material he is working, Deepak Khakar. Also the Professor Dipti Gupta ma'am, the generation portion which I have shown you the results, the pressure and this all thing, everything, everything I have done with the Professor Dipti Gupta. She is also the senior professor there in IIT Bombay. So she was only working on the energy harvesting part, means how we can improve the generations. So what is happening, by the optical material like SnO2, the zinc oxide, this all material, we can have a device. We can have a device by the nano compositions. We can make the nano composite to further improving the sensor response, and we can also give the flexible angle. This thing we have seen here. We can make a device flexible also, so that it will act as the cell power device. समझ में आ रहा है ना? Are you getting? So the concept of this material, why this is very unique, because we are making this polymers, we are making a device cell powered, and also with the help of optoelectronics we are detecting different gases, and this nature of the gas, the nature of this device is two kind, means it is generation and detection. Generation voltage, detection gases, multi devices you can see. Okay. So this is the beauty of the optoelectronics, and this is the beauty of our ATAL schemes, our workshop, that here everything is about the photonics, the optoelectronics, where we can use a device, we can use the concept which is already exists in our devices, in our inventions. So in this note, I thank you. Any query, anything? Because if you are not having any query, that means अगर query नहीं है, दो चीज़ हो सकती है, क्या समझ में, या तो पूरा समझ में आ गया, यहाँ पे कुछ भी नहीं आया. क्वेरी के लिए प्लीज आस्क द क्वेश्चन, प्लीज आस्क क्वेश्चन, कुछ बोलो, कुछ पूछो. हाँ पूछो, ऐसे पूछना पड़ेगा. हाँ कुछ बोलो, कुछ भी पूछो. If you are having any query, anything, you please ask. I also use the same concept for the solars. So what we call the solar boat. Solar boat is, there is a new concept in which we are having the solar and the flexible nature. By the wind pressure it will generate the electricity. By solar light it will also generate the electricity. In the night time because of the wind, in the daytime because of the solar. So that concept we got the patent in, maybe it is a what we call patent file, but this granted process is going on. Okay. So this every concept, if you see, these all concepts are very unique concepts and very new concepts. So this is the thing. Questions? RDX basically what is happening, we are having some tubes. नहीं RDX एक्चुअली ये चीज़ बहुत अच्छा क्वेश्चन पूछा आपने. बेसिकली होता क्या चीज़ है ना, चलो चीज़ें बताता हूँ आपको. जैसे लीकर होता है, RDX होता है, एक्सप्लोसिव होता है, पॉइजनस चीज़ें होती हैं, जैसे माना आपका साइनाइड है या फिर आपका MIC है, ठीक है, मिथाइल आइसोसाइनाइड, जिसकी वजह से आपको पता है ना भोपाल में क्या हुआ था, ठीक है। तो हुआ क्या है कि ये जो चीज़ें होती हैं ना, दीज आर वेरी डेंजरस स्पीसीज, इट डजंट मीन्स दैट यू कैन नॉट यूज, if you are using any things, maybe liquor, maybe such compounds and maybe some poisonous gases for research point of view, so easily you can use, ठीक है। and the thing is, if you see this what we call the RDS PTN, here we are having one tubes, in the tubes there are the powders of the RDX are there, RDS powder is there, from this RDS powder we are having a dedicated tube, so that it will not this what we call, because explosive gas is there, so completely protected is there, इसके अंदर भी एक ट्यूब है। अब वो ट्यूब हम लोग डायरेक्टली वी इंसर्ट दैट ट्यूब, लाइक इफ यू विल सी हियर, इसके अच्छा इसके बैक साइड में लगा होगा, फिर दिस इज द OVG, इट इज जनरेटिंग दिस व्हाट वी कॉल VOCs, यहाँ पे देख रहे हैं व्हाइट कलर का, यहाँ से VOCs आ रही है, ठीक है। और होता क्या चीज़ है, मेनली एक्सप्लोसिव के साथ जब आप काम कर रहे हैं ना, तब आप PPM वगैरह में नहीं करोगे, ऐसा नहीं होना चाहिए कि भाई दुनिया को खुशबू आ गई है तभी आपका गैस सेंसर चलेगा, तब तक तो बहुत कुछ हो जाएगा, आप समझ आ रहे हैं। तो होता क्या चीज़ है, मैं आपको चीज़ समझाता हूँ, जब आप कोई भी एक्सप्लोसिव की चीज़ बात करते हो, जैसे सपोज क्या कहते हैं, आपने कोई मिर्च का कोई कट्टा ही रखा सपोज, तो आप नज़दीक जाओगे तो आपको खुशबू आएगी नहीं आएगी, तो ऐसे कोई भी चीज़ अगर अंदर रखी है, कोई सब्जी अंदर रखी है, खुशबू आएगी नहीं आएगी, तो वो खुशबू सत्ता बहुत कम ऑर्डर में हो, मतलब समझे, कवर करके रखा है। तो यही तो ब्यूटी है, if you need any explosive sensor, so that means your sensor should be select this sensitive in the order of PP, B and PPT. If you are fabricating a device for PPM order ना, it will not help it there, क्योंकि वहाँ पे क्या चीज़ है, बाहर से ही पता चल जाना चाहिए, पता चला ये आए, मैंने बाहर से देखा, हाँ भाई दरवाजे से चले, मैंने बाहर से बुलाया, क्योंकि बाहर से तब बता पाए, कब पता चलेगा, जब बहुत माइन्यूट लेवल को भी डिटेक्ट कर ले। तो दिस इज द चैलेंज, और इस चैलेंज को ओवरकम करने के लिए जो मैंने आपको बताया था कि सेंसिटिविटी को 10 टाइम्स कर दिया हमने, तो ये चीज़ बहुत ज़्यादा ब्यूटी हुई, इस वजह से इस कॉन्सेप्ट को पब्लिश नहीं किया अभी, ये तो अब ये वर्क 1.5 साल पहले हो चुका है, इसको रोक दिया, ताकि क्या कहते हैं, इसको सीधे थोड़ा मतलब US पेटेंट या फिर कुछ बड़ी जगह कुछ वैसा करके इसको डाला जाए, ठीक है, समझे, मतलब इसको क्या है ना कि एक ट्यूब जैसी होती है, ट्रांसपेरेंट ट्यूब होती है वाइट कलर के, जैसे होली में वो सौंप जैसे नहीं आते, वो अलग अलग कलर के सफ़ेद सफ़ेद रंग के नहीं होते, होली में सौंप जैसे आते हैं मीठे वाले, नहीं आते वो वाइट कलर, वैसे दिखते हैं, आपको वैसे दिखेगा दूर से, ये एक्सप्लोसिव गैसेस, एक्सप्लोसिव RDS ना, समझ में आ रहा है कैसा, सौंप खाए ना, वो वाइट कलर वाली नहीं आती, वो हरे अंदर होते हैं कुछ, वो मीठे मीठे सफ़ेद सफ़ेद दाने जैसे होते हैं, देखने में बड़े खूबसूरत से लगते हैं, मगर होते नहीं हैं यहाँ पे, ठीक है, मुँह में समझ लेना। तो वो है, वो क्या करते हैं, उसमें से VOCs निकलती हैं, तो वो कॉन्सेप्ट हम लोग यूज़ करते हैं। हाँ, इसके लिए परमिशन लगती है, जैसे अगर हम लोग बात करें, जैसे वहाँ पे क्या था कि सिर्फ रामगोपाल राव सर का था, रामगोपाल सर के पास अपनी खुद लेबोरेटरी है इसी चीज़ के लिए, VOCs के लिए, तो इसके लिए क्या है ना कि परमिशन के साथ अगर हम लोग देखें तो एक डॉक्यूमेंट देना पड़ता है, वैसा ऐसा नहीं है, डॉक्यूमेंटेशन लगाने के बाद परचेजिंग हो जाती है। वहाँ पे तो क्या था, हम लोग के साथ ये था कि हम लोग मतलब रामगोपाल राव सर के उसमें मंगवाते थे सब कुछ, सब उनका वो चलता था, क्योंकि उनका बड़ा नाम है इस फील्ड में, एक्सप्लोसिव में, तो उनकी डेडिकेटेड रिसर्च लेबोरेटरी थी, ये इंस्ट्रूमेंट भी उनका ही है, OVG, ऑस्ट्रोन पेपर जनरेटर। सो आई वॉज, हाँ, एक्चुअली इसके लिए क्या होता है, एक ऑथराइज यूजर होता है, सो इन IIT बॉम्बे आई वॉज द ऑथराइज यूजर फॉर दिस इंस्ट्रूमेंट, नाउअडेज आल्सो इफ दे आर हैविंग एनी काइंड ऑफ थिंग्स, तो दे आर अप्रोचिंग मी फॉर दिस सिस्टम OVG। एक्सप्लोजन के चांसेस, एक्चुअली क्या चीज़ है कि ये चीज़ बहुत अच्छा क्वेश्चन इसलिए है क्योंकि होता क्या चीज़ है ना कि आपका जो भी कोई ऐसे सिस्टम है, अगर वो सिस्टम अगर माना कोई अनस्किल बंदे को दिया जाए तो दिक्कत हो सकती है। मतलब वहाँ पे क्या चीज़ है, क्योंकि इसमें जो रॉड्स वगैरह हैं, इसमें हम लोग क्या करते हैं कि फॉर्मेशन करते हैं, जैसे नाइट्रोजन का प्रेशर बना रहे हैं हम, अब नाइट्रोजन का प्रेशर जो बना रहे हैं वो -3 मिलीबार तक बना रहे हैं, तो वो चीज़ हम लोगों को मेंटेन करनी पड़ती है। सपोज अगर हम लोगों ने कोई, जैसे मानो कोई अनस्किल बंदे को, जैसे बीटेक फर्स्ट ईयर का किसी या फिर बीटेक किसी बच्चे को हम लोगों ने दे दिया सब कुछ, तो उसने पता चल रहा है कि रॉड लगाई, उसने पता चल रहा है कि वहाँ पे टेम्परेचर बढ़ा दिया है, फिर कुछ कर दिया, सो मे बी ट्यूब विल ब्रेक और समथिंग। सो इसलिए वहाँ पे क्या चीज़ है, विदाउट ऑथराइज यूजर नो वन कैन टच दिस फैसिलिटी। हाँ, सो मेन चीज़ें ये हो जाती है कि इसलिए क्या होता है ना कि इसलिए मतलब यूजुअली व्हाट आई हैव सीन नाउअडेज देयर इज अ कॉन्सेप्ट ऑफ द ऑथराइज यूजर्स एवरीवेयर। ऑथराइज यूजर है तो ठीक है, अदरवाइज ऑथराइज यूजर अगर या तो फोन पे रहे, कुछ रहे, अगर वो बोलेगा यस तो वहाँ पे बटन दबेगा, नहीं तो नहीं दबेगा। मगर है चीज़ अच्छी, मतलब इतना ज़्यादा ख़राब भी नहीं होती, मतलब कहना मतलब है कि इतना ज़्यादा डेंजर भी नहीं है। अब हम तो ऐसे लुक, ये देख रहे हो हाथ में लगे घूम रहा हूँ मैं, इतना ज़्यादा भी डेंजर नहीं होती जितना ज़्यादा डेंजर मैंने आपको लगता है। ये तो फिर भी ठीक है, अभी HMX की इमेज मैंने डाली नहीं है जो, क्योंकि इन तीनों से ज़्यादा एक्सप्लोसिव HMX होता है, ठीक है। RDS तो है ही, मतलब TNT उससे ज़्यादा है, ठीक है, HMX और ज़्यादा है, तो इतना ज़्यादा दिक्कत है। ट्यूब्स उसकी ट्रांसपेरेंट ट्यूब होती है सर, उसमें छोटे छोटे दाने जैसे होते हैं, तो उस पर क्या होता है, साइड वॉल से क्या होता है कि जब हम लोग इसमें इंसर्ट कराते हैं तो ये टेम्परेचर प्रोड्यूस करता है, तो जनरली हम लोग 70 डिग्री सेल्सियस देते हैं, तो उसमें VOC निकलती है, तो चेंज ऑन द टेम्परेचर्स वो वहाँ पे क्या करता है कि हम लोगों को VOCs का कंसंट्रेशन चेंज देता है। तो इट्सेल्फ इसके अंदर क्या होता है, MFCs और बाय डिफॉल्ट लगी हुई हैं, और वो डायरेक्टली हम लोगों को क्या करती है कि सर वो टेस्टिंग सीधे में देती है डायरेक्टली, तो ये चीज़ अच्छी होती है। इसमें जो रॉड्स वगैरह अगर आप देखोगे तो जैसे OFC की केबल होती है ना, छोटी सी पतली सी, सेम लाइक दिस वायर लुक लाइक, बहुत पतली सी, आप उससे देखोगे तो आप फूंक भी मारोगे तो मुश्किल से फूंक आएगी उसमें, मतलब इतना पतला उसका छेद होता है, जो देखने में बहुत वैसी होती है, तो उसमें बहुत हल्का कंसंट्रेशन उसमें फ्लो होता है। हाँ 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 हाँ, नहीं बहुत अच्छा चीज़ है। एक्चुअली क्या है ना कि जितनी भी एक्सप्लोसिव मटेरियल है ना, सब लाइट सेंसिटिव मटेरियल होते हैं, इसलिए क्या कहते हैं इन लोगों का हम लोग कवर वगैरह जो है ना पूरा कवर करके रखते हैं। जितने भी एक्सप्लोसिव आपका RDS HMS TNT सबके सब लाइट सेंसिटिव मटेरियल है। हाँ, क्या ब्लास्ट करना है क्या? हाँ हाँ, मैं इतना इतना अच्छा क्या कहते हैं आपका कॉलेज खाना खिलाता है आपको। हाँ, आज आपको क्या कहते हैं लिट्टी चोखा भी खिलाया था इतना अच्छा। हाँ अच्छा, हाँ, and if you need any kind of support, right now I am in the Motilal Nehru, and we are also having different program in the internship program we are having in the summer season, in winter season we are having, so the call for open to all, so people are coming from this NIT Srinagar. One student came this time from RJPT Rajiv Gandhi Patun, there is institute, one student came from the VIT student came, so there are the lot of opportunity if you want to have the this in this direction we want to work. So we are having the two things, we are having the theoretical and experimental region. In the experimental point of view I have described the things. Theoretical, what is happening when we do the fabrication, in the fabrication we cannot do the hidden trial, because fabrication process need the manpower, need the skill, and also need the money, the hardcore money. So there you cannot do the any kind of hidden trial. So what we do, prior to do the fabrication we do the theoretical things to optimize the material, because for the cost cut, simple things, because there you cannot do. If you are thinking okay sir I will start my research from the experimental, I will deny. I will say okay first you do this thing, at least you should know the basics, you should know the plotting, you should know how to write the paper. In the semester you write na, so we have also seen how what kind of things, what kind of line you writes in the exam or something. So what is happening here, basically the thing is, if you whenever you are entering in the research domain, so basically I usually call students that start with the theoretical and parallelly you do the experimental. So if you want like in this direction, if you want to do the work, so most welcome, you can anytime you can write to me, you can come to me. If you are having any kind of query also, you can call me, you can mail me, message me, and if you are having if you want to have any kind of internship, if you want to enroll, so we are having facility there also. I have also this purchased the same instrument for the flexible film fabrications. Okay, so if you want to see how it looks, how this flexible films looks, how we do this thing, so we can do this work. Okay, anything else, anything, if you are having any query further, कुछ है? हाँ, उधर उधर क्वेश्चंस लो, बोल बोल के क्वेश्चन पूछते बढ़ रहे हैं।